Yes, we have started our final webinar of the European SNS project Imagine Beyond 5G. Welcome everybody. I'm David Gomez Barquero. I'm a professor at the Technical University of Valencia in Spain, the project coordinator, proud coordinator of this project, and I will make a first introduction to the project. This final webinar focuses on the 4 facilities that we have in the project, because we have had in the past other webinars about the open call trials and pilots. So, well, just very quickly, Imagine Beyond 5G is a StreamD phase 1 project. We started almost 3 years ago. The project is finishing in March. And as you can see there, we have quite a number of verticals for pilots and trials that have been performed across the 4 facilities that we have in the project. And we have a budget of 4.4 million euros that has been distributed via 3 open calls. There you have the high-level view of the 4 facilities. We have one in Norway, led by Telenor, and another one in France, in Sofia Antipolis, in Eurecom. In Portugal, it's in Aveiro, and well, it's we have 2 sites, one at the Institute of Telecommunications in Aveiro, and also in Altis Labs. And in Spain, we have 3 sites. One is UPV campus. Second one is the Port of Valencia in Spain, and a rural site north of Madrid, managed by Nokia Spain. We also have like the labs, but all the trials and pilots have taken place in those sites. And in this final webinar, we will explain you details about each of the 4 facilities. We have had we have 4 different facilities which are very different. We have had a common architecture, and we developed what we call the Imagine Beyond 5G platform that all the facilities try to, in a way, follow to. And as you can see, we have like the verticals on top, and then those verticals have access to the facilities via APIs. A lot of work has been done in the project to make the testbeds, the facilities, open to third parties, which in our project we have had many parties coming via open calls. So I will explain you later. And then we had also a common methodology for test and validation. We had eSite, part of the consortium, and we have performed a common benchmarking of the facilities in terms of performance of the facilities themselves, and then related to the specific vertical use case application. Also, for example, in terms of security. And well, we have this reference architecture for the for the combination, let's say, of the the 4 facilities. We have the portals, and we have make use of mainly of OpenSlice, not only, but OpenSlice as a portal to the vertical end users. We also have portals for developers that you can see in the bottom. And we have also interconnected some of the facilities, and actually like Norway and Spain and Portugal and Spain, and we have made some tests and even one pilot across the 2 facilities. So regarding the open calls, as I said before, we had 3, 1 per year, basically. The strategy we follow was to maximize the impact of the budget that was allocated for open calls, and we believe that we were very successful in this sense, although at the cost of a lot of work managing 3 open calls. And we also had 2 types of experiments. One which we call platform extensions, which was used to enhance the capabilities of the facilities, and then vertical experiments to make vertical pilots and trials. In total, we funded 45 projects, and some projects they had more than 1 partner. So in total, 55 partners, companies, universities have been working with us, more than 50% SMEs. And in total, we had 8 platform extensions and 38 vertical experiments. And well, there you have some statistics, but in general, we received significant amount of submissions. So we are happy about the number of submissions and the number of and the accepted projects. And just to have like a quick look to all the vertical experiments that we have had, which is a lot, because we had 7 verticals, we have more than 25 use cases, more than 40 pilots and trials, and we have also some internal use cases for cross-facility trials. And as I was saying before, we have had webinars about the open calls that they are available in our YouTube channel. But additionally, we have videos from all the open call projects, as you can see there. And well, there are lists per open call, but you can search if you want to focus on or are interested on a specific project. So it's well, in the YouTube channel, you also have these webinars that we had about the 3 open calls. And that's the introduction. We will. Before we move, I wanted to highlight that IMAGINE-B5G has been recognized as one of the top 10 key achievements of SNS phase 1 and 2. So out of 188 achievements from different projects, we were selected for the category of vertical trials. And it was related to all the trials that came via open calls to the port of Valencia. And well, there has been a webinar that is available also in the SNS webpage, and a brochure about this. And we will the webinar next. We will go through the presentation of the 4 facilities, 15 minutes each, more or less, and then we will spend if you have any question, well, you can type it in the chat or wait until we complete the presentation of the 4 facilities, and there will be a Q&A session after the presentation of the facilities. So we will go first to the Norwegian facility. Let me see. Wait. And 1 second. So we have Min with us, which is our technical manager.
Hello, hi.
Hi, Min.
Yes, hello, hi. I'm sharing my screen now. Can you see it
I
all
can
right?
see the screen. Yes.
Yes, thank you.
Excellent.
Okay.
Please go ahead.
Yes. I will start the introduction or description of our Norway facility and the development, the capabilities, and the features that we use to support different open cores, and also how we take advantage of the platform, the extension open cores to further enhance our platform. And the Norway facility development is a long journey, and we divide the development into 3 parts. And the first is a very typical telco domain, which includes the radio access network, core network, and we do use the commercial transportation network from Telenor. And then we also develop extra edge telco cloud edges and connected with the hyperscaler clouds. Second domain is management and orchestration, because it is so difficult and complex to manage a large scale end-to-end 5G networks with so many components. And I will also show with the multiple vendors. Therefore, orchestration and management as an enabler for automation is essential. So we have a full stack orchestration architecture, starting with the infrastructure management, then move upward to network management, end-to-end service management. We also integrate with a customer-facing portal to provide one point interface between our vertical customers and our underlying 5G services. The third part is, while we have all these capabilities from the 5G connectivity perspective, then we gradually added some value-added services, starting with the testing, monitoring, and observability, which is essential for us to maintain and troubleshoot our platform in case something goes wrong. Also, it is essential for the open callers, because they also need to collect KPIs to understand how their application behave and how their application behavior is related or impacted by the network capabilities which are provided by our facility. To protect the platform, both the 5G components and also non-5G components from the open callers, we also deploy a very proper, good security framework with the firewall, with the cloud protectors. We are now in the phase to move further to deploy more applications and use cases, which then will further require network optimization, including the performance, resilience, and scalability, etc., on top of the AI. AI is so popular, and we consider AI in 2 domains. One is the AI applications from our open cores or use cases. The second part is the AI for network, that is to deploy AI to optimize and manage the network operations. So these are the 3 domains we have developed so far to the Norway facility. And in terms of how we develop, we are not on our own. We are collaborating with a group of professional world leading innovators. For example, for the management and orchestration domain, we are collaborating with Red Hat for the cloud native native Kubernetes, and also Nokia is as a partner of IMAGINE-B5G, also is a long-term partner to our platform, providing the orchestration network management and end-to-end service orchestration solutions, besides the customer-facing solutions based on intent management. Then for the telco domains, we have deployed different radio nodes from the vendors like Ericsson, Huawei, Nokia. We actually also now recently used some smaller femtocell solutions from other companies. Then for the core network, this is actually our core area for the telco domain, because we are specialized in deploying single vendor, multi-vendor, multiple slice 5G core instances to support different features and the requirements from the customers' use cases. For the value-added services, we start with the testing monitoring tools, and which are provided by Keysight inside the Imagine Beyond 5G consortium. We also have our own partners, Amblosoft, which collaborate closely with the core vendors or core partners to provide the continuous monitoring of our slice behavior, and also extend the work into the AI domain, integrated with the AI agents for closed loop automation. As a result, we have this facility, which includes multiple sites in Oslo, Fornebu and the University of Oslo, and the Trondheim at the University at NTNU. And also we have deployed a remote site in Svalbard, which is far north in Norway and the island, and which actually is a very good venue for us to explore and validate very advanced features. So in terms of capabilities, we first of all, as a 5G as a service provider, we are capable of offering multiple network slices with either isolated slices or some shared control plane functions. Because of the orchestration capabilities, we are also able to automate some life cycles of the network services, starting with the deployment. Now, we are now moving to the service assurance to further progress towards autonomous network level 4. We collaborated with our partners like Oracle and I2I and Nokia as well to enable the network capability exposure by the network exposure function and Camara APIs. We also, on top of this near commercial solutions, we also built deployed open source platform based on open source manual for orchestration and open air interface 5G core plus all-run from open air interface and the bubble run. This is the scope for the public 5G. We also have the several private 5G instances dedicated to some stakeholders like defense. We have deployed 3 network on wheels, which are private 5G networks installed on the moving vehicles, from the larger trucks to small cars. And recently, actually, I also want to show, last year, we also built an even smaller private 5G called the 5G in a box, which can be carried and deployed on demand anywhere and anytime. And the performance is pretty good. And that is a new vendor or partner we involved last year to provide the femtocell all-in-one radio unit. And then we also use edge AI devices to deploy the 5G, lightweight 5G core. So because we have now both public and private 5G networks now, so we get this open core from for the platform extension to build the PNI NPN capabilities, which is integrated with the mission critical services to support the critical service provisioning for the defense and the police. Then we also have some other telco special edge service, edge clouds deployed in different locations to support the local breakout edge and also the autonomous edge in Svalbard, which will activate the 5G core or full 5G services when the connectivity between the island and the mainland of Norway is broken. So the right side is a group of partners which are collaborating with us and contributing to the platform. So as a result, we are able to provide various 5G networks besides the public 5G with the locations in different cities, and we also have mobile and private 5G networks with different scales to be deployed anywhere, anytime. Our customers or open callers needs the 5G capability to experiment. We developed advanced features and technologies, including network exposure, RedCap, PNI, NPN, and local breakout edge and autonomous 5G to support the different verticals. Some of them require like a RedCap, some of them require the low latency, and also defense like the PNI, NPN capabilities. As a result, we are able to support a group of use cases, both from the open callers or from our own internal demands, such as mission critical services, the AI for forestry, healthcare, media, robots, and Industry 4.0. This is let me see. This is for some more details about our telco domains. For the radio part, we have used the radios from Ericsson, Nokia, Huawei to build our private and public 5G radio sites. Then for the all-round, we use USRP and Benetel are used. For the 5G in a box, which requires all-in-one radio unit, we got the sponsorship from the XM.com.core. They supplied a small femtocell which has everything built in one unit, including the antenna. And we have demonstrated this 5G in a box with very, very good performance last November. Then in terms of core networks, we have core networks is our strength because we have quite many partners contributing to different setup of the core. We separated them into multi-vendor 5G core and single vendor 5G cores. Multi-vendor 5G cores, now we have two categories. One is based on Oracle and I2I. They are specialized in network exposure and also some new services like SAP for roaming and automation. The other group of multi-vendor 5G cores is recently added to our platform, jointly provided by Axiom and the Suma Network. This time we also collaborate with a system integrator, IMAGINE, which is that actually provides a pretty good learning experience for us to do professional system integration. And this group of 5G core networks provide another features like autonomous edge and autonomous 5G and multiple slice selections. For the single vendor 5G core instances, we have 5 so far. 2 of them are actually deployed on the virtual machines now, but we are working with them to containerize their 5G core. The reason they are deployed on the 5G on the VM is because we deploy this single vendor 5G core as a private 5G solutions on network on wheels or 5G in a box, and it is more cost efficient to deploy them on VM instead of Kubernetes. But we also have another group of single vendor 5G core provided by I2I and Ethernet from HPE, and also the open air interface. These are cloud native deployed on OpenShift. In a way, we have several 5G core instances which can support different use cases and their requirements. This is the orchestration. I don't know how much time I have, David.
You can have 5 minutes more.
Okay. I will just then go quickly. For the orchestration, we have a full stack telco orchestration architecture, starting with in OpenShift and then up to the Nokia Cloud Operation Managers to manage the network service and the end-to-end service orchestrator from Nokia, which we plan to also to be integrated with the Nokia Assurance Center so that we can build a fully closed loop automation. Then on top, we are also collaborating with our business unit in Sweden, and which use Tata Consulting Service, E1, BSS as a customer portal. About 1.5 years ago, we also integrated the Nokia orchestration center with network as a code and with the intent interfaces so that we can take advantage of the LLM to interpret intent from customers directly. I will also show a figure later about this feature. On the right side, you can see that for the automation, network slice automation part, currently we focus on the multi-vendor core from Oracle and I2I. We are now also working with other vendors and partners to automate their service deployment, and also we are taking advantage of the Red Hat OpenShift AI operators and telemetry operators, so that we can monitor this multi-vendor core or a single vendor course directly from the infrastructures layer. As a result of this multiple network instances and the orchestration and the management architectures, we managed to build up a proof of concept in 2025 and won an award for the automation of the service ordering, which used the intent-based customer portal and LLM and supports the TM Forum Intent API 921 to order services of different 5G networks and with the different features to support customers from different verticals. Now we are planning to go further and to integrate the orchestration system with the service assurance system and the AI agents. Actually, we have done the integration with an AI agent in the hackathon POC that does achieve the closed loop automation. So our target is to automate and optimize the network operations. This is an overview of the Open Core project. So we support including 2 platform extensions, 5G Neptune, which is specialized in PNI and PN, and the Fusion, which complements our in-house observability framework to provide the agents or probes to collect metrics from the different 5G core network functions. Then runs the fusion of data metrics from different sources for some further analytics like root cause analysis. On the right side is the vertical experiment open callers. We have supported open course in Industry 4.0, e-health, agriculture, education, and the media. And so actually, we also have some slides for the UIO lab specialized in sustainable and immersive networking laboratories. If we have more time, Kostas can probably give some intro about the SIN lab at UIO. But that is all for the Norway facility.
Okay, thank you very much, Min. And well, yes, if someone is interested about University of Oslo lab, please get in touch. But it's time to move to the next station. We will move to the Spanish facility, and Arturo from Telefónica will present.
Thanks, David. I will share my screen. Let me know if you see the presentation.
Yes.
Perfect. Okay, so
ahead.
thanks everyone for joining the webinar. My name is Arturo Torrealba. As David said, I work in Telefónica, and I'm going to be presenting today the Spanish facility that was used in the IMAGINE-B5G project. Since the overall architecture and the IMAGINE-B5G framework was very explained by David and Min, I will jump into the facility. So here, the Spanish facility is divided into 4 important sites within the facility. The first one is Matanzas Soria, as you see here. This one is a rural site. I will explain it better later on. Then we have the Valencia port, also the UPB campus, and we have a site in Madrid from Nokia, which is also partnered of the project. All of the sites are also supported with a higher level network, which is the Telefónica public 5G network. And you will see later that we have some use cases, impressive use cases that are supported by private network and also public network. In terms of the features, as you see here, we have 5GSA and NSA deployments, not only in public network, but in private network. We are using different 5G cores, for example, Open5Gs, Kumu Core, Open5G Core. Then we have as a radio access network, we have Nokia as a vendor. We are supporting 3GPP release 16, and we are also using advanced capabilities like network slicing with multiple NSSAs and 5QIs, also in the public network. And some APIs capabilities through Network as Code and CAPIF, which is basically exposing network services through API in a secure manner. All of these services are accessed through a VPN certificate, so we provide certificates to third parties and users to be able to consume those services. We have some dashboard to monitor energy, radio status, and different KPIs, which is also an important topic in the project. And finally, as I said, we also use the Telefónica 5G network for global coverage. So we have use cases not only in the specific 4 facilities, but in the rest of the country. Regarding the UPV testbed, as you see here, we have some pictures. The first one is the radio deployed there, and the other one is an immersive lab. I will talk deeper about this. But regarding coverage, the UPV has outdoor and indoor coverage. The outdoor one is N14 and N258, which is SA, and indoor is N78. Also the Telefónica public network. And regarding beyond 5G features, basically what we are using here is slicing, not only in downlink but also in uplink, open architecture, which is also an important topic in the project, standalone millimeter wave support, RedCap, power saving features, 5QI for managing the QoS. We had also a capability which is the edge cloud computing. We deployed there an outpost, and we use several configurations, deploying a core network in the outpost on premise in the UPB and also in the region, and we tested. And some APIs capability to NAC, which is network as code, and CAPIF, as I said. As you see here in the UPB, there is a very impressive immersive lab and also very expensive. But it's very impressive. There are a lot of use cases and several services that are running over there. For example, to mention some of them, we have holograms, telepresence, XR, volumetric capture. And if you see the picture, there are several spaces to do a lot of things, holographic cabin, and there are very important use cases that were run in this impressive immersive lab. Also, as the project wanted to have some cross-facility trials, one of the ones we have done is the interlacing remote driving, which is a use case, a cross-facility use case between the UPB and the campus in Madrid from Nokia. If you see the picture, basically what we have done is to install a cockpit in the Nokia's offices in Madrid, and then the AMR was in the UPB. So you can basically remote control the AMR through the cockpit using the two different playback network and through a VPN tunnel. So in a summary, basically we had a user plane interconnectivity between two isolated 5G network. That slice that was used to manage this use case was extended from one network to the other one. So we have a extended slicing originated in one network and extended to the other one. As I said, remote driving of a mobile robot from one side to the other side. Teleoperation performed monitored by Grafana dashboard. So we were seeing in real time what was happening in the network through the use case. And we have OpenCAPIF and NAC for telemetry exposure. So you have APIs available to see what was happening in the use case. As a result, we validated that user plane interslice federation is possible to support use cases like this one, which is remote driving. And basically also another thing we were checking there is the radio characterization and end-to-end operation validation. So the other site we had in the Spanish facility is the Matanza site, which is a rural site for agriculture and forestry. As you see here, the important topic is the energy. In this site, only green energy was used. That means that there are a lot of solar panels and battery managing the energy that was consumed during the project through the different use cases and open calls. 3 slice was configured and used in this site for experimentation. There were some energy sensors for all the devices deployed there, so we can monitor the consumption of the energy and optimize it. And yeah, we have the 5G network energy monitoring, not only the devices, but also the network. As a result, 3 open calls were executed in the site, 3 use cases, different use cases. The energy that was consumed was provided by the solar panels and the energy, and was monitored by the complete phase of the use cases. We managed to improve the 5G coverage using also energy, and yeah, we had 3 specialized slices for managing control plane, user plane, use cases, and so on, depending on the depending on the use cases requirements and needs. The other side we had in the Spanish facility is the Valencia port. Here in this site, we had a mid-band deployment. As you see here, it's a 5G SA deployment working in N40 with 30 megahertz of bandwidth. an important achievement in this project is that the port side, well, not only the port side, we also have done this in the UPV side, but we managed to deploy an Open5G core using Kubernetes. If you are in this, you may know that it's a little bit difficult to deploy a core using Kubernetes because of the way of Kubernetes cluster manage the connectivity, and we have done so, and with a better performance and stability. We are also using in the port OpenSlice as an OSS and Capif for API network configuration and 5G applications. We are using Nokia all-in-one run in the port as a radio basis. And as you see here, there are some results. There is this throughput of 60 megabit per second peak and average 45 megabit per second, which taking into consideration the power and the bandwidth is a nice result. This is also a very good asset in the facility. There is a fiber connection between Valencia port and UPV. So we are able to, for example, deploy a core in the Valencia port and the run in UPV and have a cross-facility connectivity using this fiber, which allow us to play a lot with the network and the use cases, and we have done so. And there is a specific server, a Dell server, using VMware for softwareization and deploying the open calls application that are running into the project. Regarding the use of the different facilities or sites into the facilities, for example, in the UPV, we have deployed 8 open calls, 2 in the open call 1, 2 in the open call 2, and 4 in the open call 3. 2 of them were platform extensions, which allow us to improve the facility. 6 of them were vertical experiments, use cases, the ones that you are seeing in the different pictures. We have managed to successfully integrate all of them, not only the platform extension, but the use cases. We have covered 4 verticals, as you see here in the middle of the slide: media and entertainment, education, PPDR, transport and logistics, and I'm sure that we have done more than that. Just to mention one, the BNet use case, as you see here, we have a holographic cabin, and we can use this in for example, in education to have remote classes and so on. Also, the Abyss project with a boat in the Port of Valencia, which was managed remotely and controlled by the 5G network, and a lot of more use cases that are very interesting. And this deployment process and the use cases implementation have gave us some lesson learned and key takeaways. For example, a strong collaboration between MNOs and solution integrators is very necessary for successful trials, and not only for the success of the trial, but also to scale the solutions or POCs into commercial services. We have also confirmed that Beyond 5G network can support a wide variety of vertical and use cases. This is because of the advanced features, edge computing, slicing, APIs, and so on. So now the network allows a lot of new use cases to come up and to be deployed on top of the network. We have achieved most of the KPIs and KPIs that we proposed in the beginning of the project, but we have also learned that the target values have to be tailored to the different facilities. All test cases verification were passed, so we success in this too. Network edge is very important for applications in real time. This is something that we all know at this time. Network slicing is a very good asset to make sure that we have the quality of services we need in the different use cases. We have used VPN in the user plane, and we have confirmed that we can achieve a fast and reliable way to connect or to have the inter-slicing capabilities. We have used, as I said before, Keysight to measure some KPIs in those tools provide the project the way that we can measure not only the KPIs, specific network KPIs, but also use cases KPIs. And from the societal and strategic point of view, there are a lot of benefits coming up from the use cases that it wasn't before. Regarding the Matanza site, we have 3 open calls, 3 use cases, which is Campo, 5G, and 5G Ops. The lessons learned we have here is that solar energy deployment could power 5G rural deployments. I mean, it's possible to do so. A strong energy saving should be applied on radio site. So yeah, if we can monitor the energy consumption of the radio, we can turn on cells, turn off cells, depending on the needs of the use cases, and it will help to consume or better optimize the consume of energy. Remote control of drones is something that we manage there, and it's possible with dedicated slices without having latency issues. And AR glasses could be used to present friendly KPIs to an end user in rural isolated environments. So this is a rural sites. The lesson learned we had, or the hypothesis we wanted to test here, was more related to the nature of the site, and these are the main topics that we have learned here in the site. And finally, regarding the Port of Valencia, the lesson learned and key achievements regarding the port. Well, first of all, from SNS, we were included in the top 10 key achievement of the project. You can see there the tag in the right of the slides. This is because this is a real world validation of the Beyond 5G capabilities for port operation. We have done so with 5 use cases: ADAPT-G, Rescue 5G, Vir2Fix, Port Safe, and 5G ABIS. There are some pictures there about the different use cases. We have done a lot of innovative things here. And one of them was to demonstrate how advanced 5G features performs in complex, high interference industrial environments like ports. If you are, for example, a radio access planner, you might know that coverage in port is always difficult because big space and open, so all of base station will collide there. Well, as I said, this is a real world experimentation, and this helped for authorities to understand the potential of 5G. And now they are deploying their own private network in all the port, which is the next topic: launch full-scale 5G SA private network in the entire port. And also through this project, the Port of Valencia will deploy ADAPT-G and Vir2Fix as a production 5G services in this port. And this is also a key achievement of the IMAGINE-B5G 5G project. And this is all from my side. Thanks a lot, and I give you the floor, David.
Thank you, Arturo. There was a comment, a question already in the chat, but we will discuss it at the end. And now it's time we move to the Portuguese facility, and we have Fatma from the Institute of Telecommunications of Portugal in Aveiro. She will present the facility.
I am Fatma. Good morning, everyone. I am Fatma Marzouk from IT Aveiro, and through the slides I will be presenting the Portuguese facility, focusing on mainly its capabilities and contributions within the IMAGINE project. The main feature of the Portuguese facility is that it leverages both research and commercial graded solutions to provide a real-life citywide environment for developing and validating Beyond 5G solutions and applications. So at its core, and as it can be seen by the figure, the facility involves 2 main data centers, one that is hosted by IT Aveiro and another one that is hosted by Altis Labs, which make it a sort of multi-domain environment. with each domain having its different 5G, beyond 5G solutions, which also ensures versatility. As it is seen, as it can be seen from the picture, the facility is distributed. The coverage of the facility is distributed across the city of Aveiro and features different outdoor and indoor 5G new radio deployments. So to cite a few outdoor locations, such as within Aveiro Seaport, where we have 3 industrial antennas providing coverage, which could always provide an ideal setting for transportation and logistic use cases. The area also features small cells with small small cells and distributed small cells across the city of Aveiro with small edge devices and fiber deployment, which can always extend the coverage and resources to other verticals such as PPDR and e-health. We also have indoor locations within IT Aveiro and Altis Labs, and within the project lifetime, they have been serving to validate the early proof of concept phase for several of the open call project within IMAGINE. We also have a 5G node within an electrical substation within University of Aveiro, which could be leveraged for energy management use cases. And ultimately, we have portable 5G standalone network solutions involving different open source cores, which can be paired with different RAN types. So it provides us a sort of some network on demand solutions whenever and wherever the 5G coverage is needed. So this figure depicts the architectural overview for the Portuguese facility, and is, as I have just stated, it is divided strategically across 2 domains, domain A of IT Aveiro and domain B of Altis Labs. So domain A, it brings different 5G new radio deployments that can be connected to different 5G core solutions, including the commercial graded Huawei core network, but also other cores such as Druid and as well as other open source, open source core cores we have available. So domain B of Altis Labs, it rather follows an Open RAN architecture and explores the 3 available 5G cores that Altis Labs has, which are Druid, Open 5G Core, and Open 5GS. The facility is also empowered with a network orchestrator based mainly on OSM and an end-to-end service orchestrator, which is OpenSlice. And here OpenSlice has been used to mainly expose the Beyond 5G services to the vertical customer. As it was stated since the beginning of this webinar, we also have the unified tools from key sites being used and integrated within our facility for testing and validation purposes. In terms of technological capabilities and beyond 5G features, the Portuguese facility has exposed to the vertical customer a set of capabilities, if we can cite a few. This includes advanced 3GPP technologies with a fully functional and validated 5G standalone network following release 16 and with some release 17 features available. With an open and scalable architectures that can accommodate variable and diverse vertical use cases with varying requirements. dynamic slicing, where the network slice performance can be adjusted on the runtime, but also custom slicing, where the performance can change according to the vertical requirement. The facility features also different infrastructure options, which allows for the exploration of PNI and PN scenarios. It allows for hosting third parties, containerized and virtualized network applications, and ultimately, as part of the contribution that was brought by some of the platform extension that were hosted, the Portuguese facility also extended its capability with accurate positioning, as well as an extended Open RAN coverage and capabilities. So through the three Imagine Open calls, the Portuguese facility successfully validated 11 vertical experiments, spanning strategically across 5 verticals, including PPDR, Industry 4.0, e-health, transportation and logistics, and media. So in terms of e-health, the objective was to leverage the Beyond 5G connectivity for validating the use cases of digital health and remote care services. Trials and open call projects such as Drone Care Angel, CHHA, and Cognet Care addressed diverse scenarios, including mobile healthcare and emergency monitoring with drone and sensors, rehabilitation tracking, remote cognitive and motor health monitoring, and that by relying on different Beyond 5G features from the facility, including low latency connectivity and ultra reliable uplink transmissions. The trials could demonstrate they enabled a real-time exchange of video and biometric health data. And as a result, this could demonstrate that Beyond 5G connectivity could move the traditional the healthcare beyond the traditional hospitals to enable accessible and remote healthcare, as well as scalable preventive monitoring. So for Industry 4.0, the objective there was to validate Beyond 5G connectivity for smarter and more efficient industrial environment. Trials such as UltraFab 5G, NeuroNet, Wings addressed diverse scenarios such as real-time factory monitoring, deterministic networking, as well as energy-aware optimization using AI. These trials leverage features such as dynamic network slicing for prioritized traffic and flexibility while doing so. Also edge processing for low latency processing, as well as AI-driven optimization for the energy usage. And results showed that the facility could, or the Beyond 5G features could support flexible industrial automation, operational efficiency, as well as sustainability, while mainly reducing the reliance on the wired infrastructure. So within PPDR, the focus was mainly on the contextual awareness under emergency scenarios, and trials and open call projects such as within safer flow and critical combine the use of different well, if you can say sensors, environmental sensors, wearables, as well as also drones. In those scenarios, the critical aspect is also is always reliability, and as a result, the trials could demonstrate that that Beyond 5G could contribute to faster decision making and safer emergency operations. For transport and logistic, so the trials looked at mainly connected mobility and autonomous logistic, combining smart tolling, autonomous delivery robots, and here and that always supporting a critical aspect, which is advanced positioning technologies, and mainly here relying on GNSS signals, but also the 5G network localizations, combined with low latency from capability from the facility. The trials could demonstrate they could enable real-time transaction and navigation, which are key for intelligent transport and automated logistic services. So under media, we had N2XP, which was an open call project that addressed the immersive media and smart tourism, combining the use of extended reality, AI-driven personalization, as well as edge computing for low latency media delivery. And results prove that with advanced connectivity from the facility, this promotes to enable new digital tourism and immersive media experiences. Besides the vertical experiment, the Portuguese facility also hosted two platform extensions. The first one is SRS RAN, which was about an open RAN deployment with 5G RAN positioning support, also with FlexRIC integration through the A2 interface. That extended, so this platform extended the open RAN for Altis Labs, adding 3 outdoor cells and expanding the programmable RAN capabilities. Now, the second platform extension was a telemetry and exposure platform that provides visibility into compute and energy metrics across the infrastructure, which enables sustainability-focused experimentation and energy-aware optimization of the infrastructure. And here, this platform extension was done on IT Aveiro data center. So the two platform extensions further strengthened the capabilities of the Portuguese facility, and they were validated within the project lifetime with two. With each of them was validated with a vertical experiment. So I think I'm reaching to the end of my slides. So in conclusion, what we wanted to show, or what the Portuguese facility I think managed to show, is that the Beyond 5G experimentation is not just theoretical. It could be validated in real life, citywide environments, as it was done within the context of IMAGINE. And within this broader IMAGINE Beyond 5G ecosystem, the Portuguese facility contributed by validating diverse use cases, vertical use cases, and trials. These trials leverage different Beyond 5G features from the facility, such as the dynamic network slicing, such as the positioning, the Open RAN, the edge computing, etc. And in turn, this also reinforced the capabilities of the platform, thanks to the platform extensions. And ultimately, this contributes to strengthening the role of the larger scale European testbeds in moving the research on advanced connectivity to real societal and industrial impact, actively shaping the roadmap toward 6G, ensuring that the future networks are built on solid and real-world insight. And that's all from my side. Thank you all.
Thank you, Fatma. So let's
I hope I
move to
maintained the time.
Yes, we are doing fine. Thank you. Let's move to the final presentation. Last but not the least, we have Karim from Eurecom that will present the French facility.
Hello, everyone. Do you see
hello.
my slides?
Yes, we do.
Perfect.
Please go ahead.
Thank you for attending the webinar. I'm Karim Boutiba, a research engineer from Eurecom, and today I will present the French facility. I will start with a short overview. Then I will list the main achievements of the French facility during this project. Then I will give the main RAN and core network beyond 5G features. Then I will move to the open call platform extensions and vertical experiments. And I will conclude the presentation with a few lessons learned during this open calls. So the French facility has one site located at Eurecom in Sofia Antipolis in south of France. The facility has three parts, as you see in the above figure. So the first part is the portal and the APIs. This is the entry point of the facility where the verticals, the researchers, and the developers will access the facility. The second part is the 5G connectivity. So we have the RAN and the core network based on open source, open interface platform. And the third part is the orchestration and management framework, where we have our homemade orchestrator based on the top of OpenShift and Kubernetes clusters. So regarding the 5G connectivity, we have indoor and outdoor deployments of 5G standalone. So for the outdoor, as you can see in this picture, we have two Binetels radio units, which are ORAN compliant, and we have also VVDN radio units. And this is the experimentation area in orange, while we can fly drone and they can go up to 1 kilometer from this area. And for millimeter wave, we have microamp radio units also for outdoor, while for indoor, we have many radio units in this area inside the building. All these components, the RAN and the core network, are running as Docker containers on the top of Kubernetes and OpenShift clusters. And we can support the three types of vertical experiments. For URLC, we can achieve an RTT lower than 5 milliseconds. For millimeter wave, we can go down to 2 milliseconds. For IMAGINE-B, we have throughput up to 1.4 gigabits per second in downlink and 300 megabits per second in uplink. While for MMTC, we added the support of RedCap devices to support to reduce energy consumption. Besides, since we are using open source, we can customize the different network functions, either at the RAN side or the core network, to accommodate the verticals needs. Now I move to the main achievement during the project. I mentioned 4 points. before and after, during and after the projects. So before the projects, we had the monolithic run. So it's a single components of GNodeB, which runs directly without open interfaces. After the project, we added the support of the different ORAN interfaces, mainly the 7.2 between the distributed unit and the RAD units, and we have tested this with the multiple RAD units from different vendors. We have also added the support of the F1 interface. We had previously the one from 3GPP, but we added the extensions from ORAN as well, and we have tested also with the Acceleron CU and Light-on RDU, with the E1 interface and the E2 interface between FlexRig and the CUDU. So for the E2 interface, before the project, we had some customized service models. Within the projects, we have added support of KPM and RC service models, which are fully compliant with the ORAN specifications. The second point is the core network. So before the project, we had an operational core network with basic operations, attach, PDU session. And during the project, we added the monitoring services. For instance, the event exposure from the different network functions, the NWDAF, the network data analytic function, the NEF, and the graphical user interface to monitor and to configure the core network on the fly. The third point is the upgrade of the run release. So before the project, we were at release 15 and 16. And during the project, we added the containers for release 17 and two main functionalities, RedCap support and short two-step RAT with short data transmission. The final point is regarding the APIs. So before the project, we had some proprietary orchestration and management APIs. And during the project, we leveraged the Camara and TMF to build extra APIs, which are standardized, on the top of these proprietary APIs. Now I will move to the Beyond 5G features in the run. So the first feature is the open architecture. As you can see in this picture, we see the run architecture with the different interfaces. We have some ORAN interface, E2, O1, F1, U, and the 7.2. We have 3GPP interface F1C. We have a small cell forum FAPI interface between the MAC and the physical layer. And we also kept the proprietary interfaces based on UHD for USRPs and ECP for some split 8 radio units. So this makes the architecture very open and interoperable with the different vendors, which are ORAN or without ORAN support. The second point is the release 17 support with the two main functionalities, the RedCap and two-step RAT with short data transmission. The third Beyond 5G feature is the support of millimeter wave standalone with the ORAN compliancy. Here we use two different radio units, one from Light-on and one from microamp. The fourth Beyond 5G feature is the AI and ML through the near real-time rig, in our case FlexRig, where the developers can write their own X-app, implement their own machine learning models, and deploy them on the top of facility to monitor and control the radio access network. And the final point is the energy consumption. While adding the support of the RedCap, we reduce the energy consumption of the user equipments. And also we power 30% of our needs using solar panels on the top of Eurocom, since we are in the sunny area. For the core network Beyond 5G features, we have two features. The first one is AI and ML through the NWDAF. So in this project, we created an open source NWDAF. These are the different functionalities of the NWDAF. We have implemented 4 of them: the UE abnormal behavior, the communication statistics, mobility information, and network performance computation and prediction. The second Beyond 5G feature is the API's exposure via the NEF and the discovery via the CAPIF. Now I will move to the OpenCall platform extensions. During the project, we had 2 extensions. The first one is the Camara APIs. According to the name, the purpose of this project is to build Camara APIs on the top of the facility, including the Edge Cloud APIs. This Edge Cloud APIs will be interconnected to the private orchestration framework of the facility to deploy application and services on the edge of the facility. Also, they have implemented the device location and the APIs and device identifier APIs, which has been integrated with the Open Interface Core Network to consume the required data from the network. For the second platform extension is the F extension. So this F extensions, in fact, has 3 different extensions. The first one is proactive beam switching based on video sensing to avoid signal blockage. With this extension, they have also corrected some bugs in the millimeter wave implementation, and these corrections are pushed to the main Open Interface GitLab repository. The second extension, or let's say sub-extension, is the 2-step arch implementation. And the final one is the core network graphical user interface. For the vertical experiments, we had 5 projects. 1 for education vertical and 4 for PPDR. For the education projects, ProServe, the purpose is to deploy a ProServe orchestrator in Eurocom's Edge network. And this orchestrator will consume the NWDAF API to get the location of the users. So when the users are near each other, for example, in the same room, they will share information or data between each other via sidelink, direct to direct communications. So device to device communication, sorry. So they avoid consuming 5G resources to send the data through the GNODE B, and also they reduce latency between each other. And if the users are far from each other, they will use a 5G network. We have also the FireScan projects. Here the purpose is to integrate their systems with the Airbus AgNet communication platform to receive instant fire alerts and provide live video transmissions to firefighters. The third project is the 4.5G. Here, the purpose of this project is to detect smoke and detect user for assistance in the context of fire emergencies. The airway project, here the purpose is to visualize the meteorological risk of for the safe use of aerial means. So, and for the final projects, the 5G Fire, here also the purpose is to use AI in Eurocom Edge platform to detect smoke and send alerts to firefighters. To conclude this presentation, I will provide a few lessons learned during the execution of the open calls. So the first lesson is open source private 5G differs from public 5G networks. So in our methodology, we said to open callers, try first your system in public 5G to validate that the drone can connect to 5G and your application is working. Then you bring it to the private 5G, and then we can compare the performance. However, we had some issues. The main issue is that for in the context of public 5G, the PDU session is pushed by the network, so the UE does not request for PDU session. And when they have tested this with commercial network, they just switch on the radio, and the UE connect directly to the network. While in the open source private 5G, the UE need to request explicitly the PDU session with the DNN manually entered and also the slices information. So this added some complexity to troubleshoot and to access their system with their tools to modify and to request PDU session. The second lesson is the applications must be 5G aware. So in the context of 5G, we can have connection establishments, temporary failures, dynamic network behavior, even for few milliseconds, like 2 milliseconds. If you lost connection, the network has some recovery procedures specified by 3GPP. However, if the application has TCP sockets and there is no connection, they drop the connection and they will not work anymore. And in this context, they need to stop the application and rerun it again. So if the application takes this into consideration to be 5G aware, they can tolerate these reestablishments and temporary failures to reestablish the connection, and it will be seamless for the user since it's for few milliseconds it can happen. The third point is the user equipment readiness. So here, everyone use his own setup with his own interfaces for the user equipment. So if there is a problem, we need to troubleshoot using his own setup. But if we provided platforms for user equipments with clear data plane and management interfaces, this will avoid all these efforts, and we just give them the user equipment. They connect it through USB, for example, or M2 interface, and then we provide the switch on and switch off APIs to turn it on and off, request video session, etc. The fourth point is the interoperability of O-RAN devices and components. So the first idea is that we can think about if two components respect O-RAN specification. If we bring them together, they will work straightforward. However, in practice, it's not the case, and this is caused by the interpretation of O-RAN specification and different configuration of the components. So it requires some efforts to do the integrations, especially for the 7.2 interface and the F1 interface. The last point is the end-to-end automation, since we are in an environment where we will add different features, not only for this project, but also from other projects, from the community to the platform. And end-to-end automation is essential to ensure that all the different contributions are still working, and one contribution does not miss with the other contributions. That's all from my side. I give you the floor, David.
Yeah, thank you very much, Karim. And sorry, no. There has been now we have a few minutes for questions and comments. There have been some in the chat that I have tried to address. I can now elaborate maybe a little bit more. There was first a question about the latency end-to-end in this remote driving experiment. Remote driving experiment was, well, within the Spanish facility, but between Madrid and Valencia. And the the key for the innovation, let's say, we demonstrated was to have two like end-to-end two slices in two different private 5G networks synchronized and aligned, although in one network it was the uplink was being used, and in the other one also well, the uplink on one side is the downlink on the other side, which it's a bit tricky, and when we go to the second question, I'll elaborate a little bit on that. And well, latency end-to-end was a little bit more we have had statistics around 100 milliseconds. The end-to-end latency includes several steps, and at the end with 5G, you could say that the wireless network is not the bottleneck anymore, or or at the end you have like sometimes the video codec and some other elements that introduce a larger latency. We submitted actually a paper to the UCNC conference on this pilot. It's under evaluation. If it's accepted, it will be presented there. But in any case, in March, there will be several final deliverables of the project, one related to the trials, one related to the validation. And if you are interested on a given use case, you will have to look at several documents because, for example, we have a work package which is on the use cases definition. So you will have to take a look to several documents to have all the information for a specific use case. Then there was also a very good question on the uplink downlink ratio, the TDD pattern. Well, as you know, in the public networks, the TDD pattern is favors the downlink. And because we in the facilities we have used the public networks, which cannot be modified, but also the private networks, and then there you have flexibility to change or choose the TDD pattern that is most suited to the specific use case or vertical. But I have to say that depends on the equipment you are using. So it's not that all equipment supports all possible combinations in the standard, which are a lot. So in our case, for example, here in Valencia, we support 2 and soon a third one. But in general, most of the use cases, they are the bottleneck is in the uplink, because we have some robots, some machine cameras that are connected to the 5G network, and then we have to deliver that information to the in the uplink, right? So I don't know if seems there are no more questions, so we will conclude on time the webinar. Thanks a lot for your time, and yeah, if interested, please take a look to our YouTube channel. You have videos from the open callers, also webinars. And as I said before, pay attention to the final deliverables that will be published. They will be submitted at the end of March. So during April, they will be available in the project webpage. So thank you for your attendance. Thank you also to the presenters and their great presentations. And we conclude the event. Bye.